Hi-oh, here we are again. Momentum, the big mo. Yeah, here we go. Momentum. Basically, you can talk about it as inertia. Inertia in motion. Think about what inertia is. Inertia is all about mass. So it's mass in motion. So what does that mean? Think about that. It's mass in motion. Inertia in motion. When something has a lot of momentum, usually we say, well, it's unstoppable. It's very difficult to stop. Why is that? Because of its mass, typically. It could be going really fast. You could have a bullet. It doesn't have much mass, but it has a huge velocity. So it turns out momentum is the product of mass and velocity. We use a P to represent momentum. M, of course, is mass. And V is velocity. And of course, your units. Think about it. Mass is in kilograms. Velocity is meters per second. So momentum is in kilograms times meters per second. Or we just say kilogram meters per second. So let's see what you know. Think about the formula. Which has more momentum? A parked bicycle or a parked car? Well, of course, neither has more. In fact, they both have 0. All right? Doesn't matter about the mass, because if the velocity is 0, the momentum is 0. Let's try a calculation. What's the momentum of a 3 kilogram rock, that of course is mass, that's traveling at, so there's your velocity, 30 meters per second. Momentum is mass times velocity. Mass is 3, velocity is 30. 3 times 30 is 90 kilogram meters per second. Let's look at it in terms of a more conceptual nature. Let's compare two cars. Same speed. Think about this, right? Same speed. Momentum is mass times velocity. This part, we're not changing. But one has 3 times the mass. What happens? Tell me about the momentum of that more massive car. Well, the way I've taught this in class before is think of it as a teeter-totter. If suddenly we make this one 3 times greater this side, the teeter-totter is going to go, vroom. It's going to fall. We need to balance it out, so what do you have to do? Well, since we're not changing this velocity, the only thing we can change, and that's what we're asking about, the momentum, is this side. So it's going to be 3 times the momentum. And lastly, let's imagine dropping a couple of balls. One of the balls has more mass, so imagine that. There's one, and there's the other. In comparing those two, the more massive ball, tell me about its momentum. Well, momentum is mass times velocity. Well, if the mass is greater, that means the momentum's greater. There you go. What about the speed? We're dropping these things. Think about this. What do you know about two objects falling? That's right. A hammer, a feather, it doesn't matter. Get rid of air, and they fall at the same rate. And what about acceleration? Negative. We like to round it to 10 meters per second, or negative 9.8 meters per second to be a little more precise. So that's the same as well. And there you have it. Momentum.